As you see, the future is going to be very exciting to see a lot more UAVs or drones in the skies, but it needs to come in a safe way. These systems use GPS technologies, more accurate GPS called RTK, a real-time kinematic, LiDAR payloads for laser inspections and to get precision. Different kinds of information is going to be gathered from these systems that fly autonomously. But to make them safe, you need to have a very solid flight plan, very safe way to use. I'm not sure if the audience is familiar with something called geofencing. In some areas, you don't want to fly. The beauty of it is that you can program these systems to actually not fly over areas you don't want to fly. It's a very simple technique. It uses very different GPS points, and it is programmed in to say, do not fly over here. The drone will know it should not go there. You don't even have to, the person doesn't need to be even aware. You're near an airport. The drone should not fly when a plane is taking off. These drones will get smarter and more intelligent, and geo-information is what makes it happen. Definitely, what drones are all about is the data they gather. And the amount of data that they gather, what we do is we take 100 pictures on your phone. You're looking at transferring about 200 megabytes of information. When a drone flight, you're talking about up to 50 gigabytes of information. All this is useful only if it can be processed. Otherwise, we cannot go through this amount of information. So computers will help us process this information. And what a drone is what we call is one of the devices. If you look at IoT, every device, even your smartphone, is an IoT device. Even a drone is another device that is actually collecting data and transferring it to a cloud. So connectivity, cloud, and devices become part of what we call is the IoT ecosystem, and the UAVs will be a big part of it in the future. There's two parts of how data is gathered. And when you look at a drone, you got to think of it in three pieces. One is controlling a drone. That has data communications as well. We call it command and control. Then there is data that's collected on the payload, which means you're transferring a video or you're transferring a picture. That we call is a data packet that's coming from a drone to either a cloud or to a device. And then there is what I do with the data. It gets transferred to a cloud, or it's locally on a PC, but then you visualize that information, and that is like viewing it on a tablet, viewing it on a phone, or viewing it on a computer worldwide. So it is now stored in the cloud, and you can look at it in different places. So you're looking at three different parts of the tool chain, and communication is important in each aspect of it. And when I say communication, it is like using wireless communications like Wi-Fi or LTE, even 5G in the future. These become your connectivity points, and all these devices will be interconnected in the next decade. And you will see that what it's really doing is volumes of data that's transferring from one point to the other, getting analyzed and making useful information. End of the day, it's not what the data is, it's about what can it tell me. So do I need to fix something? Do I need to repair something? Or everything looks good? This is what we need to know, and that's what this whole data processing will help us get there. If you see the future, the world will be fully connected, and more like an autonomous car, where it's a self-driving car, to an autonomous plane, which is a self-driving plane or a drone, or even a robot for that matter. They're all getting smarter, and smarter in ways they're helping humans. Now, where a majority of accidents that happen, you'll be amazed to see how much of it is a human error. So we want to rely on systems to help reduce that, improve our lives, improve the safety in our systems we use. So this whole network, is how does it work together? And geospatial information is what keeps the coordinate systems to keep where they are located at any given time, to be able to be interconnected at any given time. That's what enables it. So you will never ever see a geospatial network, but you're always experiencing it every day. Even today, your smartphone, as you drive and get driving directions, you're actually using a geospatial information. Yes, this is called preemptive protocols. What it means is that as more and more urgent things are to be done, how do you ensure there's a reliability and dependency on such a system? For example, you want to call an emergency phone number, and for a hospital for an emergency, you want to always be assured that you can always reach through that number. You don't want that network to be clogged. In a similar fashion, information has different levels of priority. When you're driving in a car and you are looking at the future where there's autonomous driving, the immediate maps, anything that changed, if there's a new obstruction on the road, you want that information real time coming to the car. And at that level, those are the information you don't want to compromise on. So you definitely see prioritization. How it instantiates itself, some of it is going to be real time on board. Some of it is like, you think of it as cached servers around poles that are locally communicating at a very fast bandwidth. So you're going to be able to get real-time information. Some data is large data sets. Some are actually, much more smaller bursts of information. But depending on what the requirement is, you will see a very matrixed communication network that is using geospatial data, knowing where the data is needed to come, and then what kind of network can be used. And I think that's where 5G, the way we think of it, is what's going to revolutionize how all these different networks can work seamlessly together. Definitely. In fact, extending beyond this convergence is machine learning, application-specific analysis, even deep learning. What I mean by machine learning and deep learning is, for example, cracks on a building, or you want to look for a certain deformation. You can actually program computers to track and look for this. So you don't have to look at the full system, you can look for specific problems. And that's what machine learning enables. But how do you get there? First, you need to pre-process a whole amount of data so you can improve your accuracy of detection. And so that's how it's going to instantiate itself. And so all these pieces is where you are going to get information. And then a real good example today of how this is helping is I don't know if you use Google Maps as you drive, telling you there's a traffic jam, telling you take a detour. This is all analytics. This has actually processed a lot of information, looked at where congestion is, and it is giving you a route so that you can get to your destination faster. So artificial intelligence is a very up and coming field, and Intel is looking at it. By the way, Intel has solutions all the way from compute chips at the smallest level that go into watches and wearables to servers. Machine learning, artificial intelligence, they're all exciting terms, but what it really means is there are different specific compute engines that are specialized in delivering these capabilities based on an application. So we have tools. We announced the potential acquisition of Nirvana, which is actually an AI software company that runs in the server, to an intent to acquire Movidius, which is an AI solution for machine learning with a very small chip that can be at the edge of an IoT device. And when I say edge, it's onboard computing. So there are different tools that Intel has. Intel has storage, 3D cross-point memory. We have accelerators from Altera or the FPGA, programmable chips, to mainstream computing capabilities and graphics capabilities. All of these help in defining what artificial intelligence processing is needed for a specific application. So whether you're doing a speech analytics, or you're doing image analytics, or you're doing video analytics, they all have different needs. So we at Intel have the compute requirements that can meet a wide variety of applications, including solving for the next cancer using genetics and genetic analysis. Even that, in some aspects, is cloud the artificial intelligence techniques applied in those. So this is how computing can help us and do things that couldn't be done before. And we at Intel look forward to using our tools, our capabilities in enabling this ecosystem with some of these futuristic use cases.